Hello, welcome to AP Environmental Science Unit 3. Today we'll be talking about populations. At the end of this unit, you'll be able to understand survivorship graphs and different types of populations and how they are affected by their environment. So, there are different types of species. Two different types, generalists and specialists. And they each have their own pros and cons. Generalist species have a really broad ecological niche or range of food and habitat tolerance. While they also have an advantage in greatly in constantly changing ecosystems. So, generalist species are really good in habitats that are constantly changing, and they are also really good when they are invasive. However, specialist species are organisms with a really narrow niche or a narrow set of food or habitat requirements, and they are advantaged in more like stable ecosystems, which means they are more advantaged in ecosystems that just don't change, which means um, they are more condescending with the generalist species. So generalist species will thrive in environments that they are invasive to, while specialist species will not thrive. Next up, we got R selected species and K selected species. Now, these are different from this. These are also species types, but they are selected species types. And R selected species are capable of a really high population growth rate. Think like rabbits, for example, but usually small and reproduce quickly. So think about fish, really, in reality. And they run away from their offsprings. They don't care for their offspring. While K-selected species do care for their offsprings, and they're typically in populations that are at or near carrying capacity, and larger organisms and longer lifespans. So, tell me why you think which species is better in a constantly changing environment. Which species is more generalist? Next up is biotic potential. A biotic potential is the maximum number of offsprings a species can produce. So, like we saw earlier, it's near its carrying capacity. Survivorship. Survivorship is the percentage of individuals of a given species that are still surviving at any point in the typical lifespan of that species. This is a survivorship curve. As you see, the K-selected species is a solid line, it has a curve, while the R-selected species is the dotted line, and it's another curve. The R-selected species has a rapid population decline, then it starts to even out as time goes on. While K-selected species starts to live on, and it slowly goes down and rapidly declines towards the end of its lifespan. Why do you think this is so? So, like explained earlier, carrying capacity is the maximum number of maximum number of individuals a given species can support. While distribution has two different types of distributions. Uniform distribution, you might know these from your algebra class. And a uniform distribution is roughly equal space between each individual in the population. While clump distribution is animals that form herds or schools for protection against predators. Now let's look at a graph. So, as you see, the y-axis is percentage of organisms surviving, while the x-axis is the time. As we see, we got our species right here, and this is our carrying capacity. Our species rapidly inclines, but as soon as it meets its carrying capacity, it starts to dip. Then when it dips below carrying capacity, it rises again, and once it goes above carrying capacity, it dips again. It goes back above, and then it dips very quickly, and then the carrying capacity dips. Why do you think this is so? Well, I'll tell you why it's so. Sometimes, when species dip over the carrying capacity too much in a certain time frame, the carrying capacity itself lowers because it will never be able to reach that height that it used to have ever again because of how much of its resources have been used. Now, we'll look at density-dependent factors and independent factors. Dependent factors are the effects are greater at greater population density, while independent factors are limits population growth regardless of density. So, this will limit population growth no matter what, and this will limit population growth depending on how many populations there are. Now, we do need to know this formula, and that is the crude birth rate and death rate formula. So we need to know the percentage growth rate, which is CBR minus CDR all over 10. What they stand for is the crude birth rate minus the crude death rate divided by 10. So after you get that, let's say the birth rate is 50 and the death rate is 30. 20 divided by 10 is 2. To get the population doubling time is 70 divided by 2. In this case, it's 35. So it'll be 35 years until the population doubles. This is one of the most popular formulas that are seen on the environmental science exam. So I would really write this down in your notebook and keep on studying it until your exam is over. Next up is replacement level fertility, and that's simply the number of children a mother must have in order to remain the same growth rate. For example, the United States has a replacement level fertility rate at 2.1. So each parent must have 2.1 children. So the reason why it's 2.1 is so that way we have one kid to replace the father and one kid to replace the mother. And the 0.1 represents natural deaths that occur and to make up for people who do not have kids. So let's practice. In your notebook, write down these 3 questions and we'll go over them here in a second. Explain which species you think has a better chance of surviving, K or R selected species. Example 2. Identify an effect of declining percentage growth rate among hermit crabs. Example 3. Explain the key difference between the offspring bonds with parents between K and R selected species. I'll give you a second right now. Alright, so explain which species you think has a better chance of surviving, K or R. Well, let's look at the facts. A K-selected species has less population, but they care for their offspring, so they're more likely to survive. While R-selected species populate fast, but less of them are likely to survive since they don't care for their offsprings. So K would be the best answer. Example 2. Identify an effect of declining percentage growth rate among hermit crabs. A declining percentage growth rate among hermit crabs would result in them eventually dying off or not being able to reach a good comparing capacity as they once had had. So I would put a lower carrying capacity as your answer. And on identify questions, I would recommend putting a full sentence just to make sure you get the points. Example 3 is explain the key difference between the offspring bonds with parents between K and R species. And we kind of already explained that in example 1. K-selected species care for their children, while R-selected species don't care for their children. If you understand all that, you got it and you're ready to move on to Unit 4. You are now 1/3 done with environmental science. Pat yourself on the back for that. Until next time, see ya.